towards the binomial expansions question, we need to make this be written in the form so that it's got a negative, and in this case fractional as well, power. A root is going to be a power of a half, and it's on the bottom of a fraction, so that's going to be 4 minus x to the minus a half. And we want the first three terms. The formula for the binomial expansion is in your formula booklets. But the first three terms is going to be 1 plus nx, where n is the power, and then plus n times n minus 1 over 2 lots of x squared. So we can't actually use this yet because this is the expansion for 1 plus x to the power of n. So we've got a little bit of work to do before we can have it in that form. We need to get rid of this 4. We need to turn that into a 1. So to do that, I'm going to concentrate on this 4 minus x. And I'm going to take out a factor of 4. If I take out a factor of 4, we're going to have a 1 here, and we're going to have to divide this by 4. So this to the power of minus a half is the same as this to the power of minus a half. And I can apply the power to each of the two terms that are being multiplied together to give me 4 to the power of negative a half times 1 minus x over 4 to the negative a half. And this is now in the right form. So 4 to the minus a half is 1 over the square root of 4. So that is a half. So I've dealt with that. And now I'm going to times it by the expansion of this, which we've just said we're going to use this formula for. So first term's 1. Second term is going to come from the n term times the x term. And I like to write everything out with brackets first and simplify everything afterwards, just so that I know I'm going to get my method marks and not make a silly mistake with the signs and things like that. So the next term then is going to be n times n minus 1 times x squared and divided by 2. Okay, so then that simplifies. If we simplify each term, we're going to get 1 for the first term, we're going to get x on top for the second term, and 2 4s are 8 on the bottom. And then for this x squared term, we've got a 3 and a positive x squared on the top, and we've got 2 negatives here which also make a positive, so that's positive 3x squared. And then we're dividing by 2 times 2 times 2 times 4 squared, so that's 16 times 8, and 16 8s are 128. And then the last step is to multiply the half in. So we're going to get half plus x over 16 plus 3x squared divided by 256. Now the other thing, they've not asked it on this question, but the other thing that's worth mentioning is the values that this expansion is valid for. This will be valid for when the modulus of x over 4 is less than 1. It's always when this term is less than 1, and in this case it's x over 4. If we bring the 4 out of the modulus sign, which we can do because it's positive anyway, it's a positive number, that's saying that the modulus of x needs to be less than 4. Or the other way you can write that is that the x needs to be between minus 4 and 4. B says we can do 2 substitutions to work out an approximation for root 2, because all of these have a root 2 in their answer. And it says one of them shouldn't be used. Now I've just said in part A that the expansion is valid as long as the modulus of x over 4 is less than 1, which means that the modulus of x needs to be less than 4. Now, so that's x being between minus 4 and 4. So if we look at that, then it's the top one, x equals minus 14, is not valid is not suitable. Because it is not in the valid range of values that x can take. Okay, part 2 then says which one will give us the best approximation, and it's going to be the one that's closest to 0. The smaller x is, the quicker the higher powers will reduce to really small negligible values. So the answer is going to be the -1/2 will be give us the most accurate. Since it's closest to 0.